All right, welcome back. So we've been looking basically at this problem for the first couple of videos here. So we've been looking at sine of n of x cosine mx dx, okay? And we've looked at so far the case where n and m are both even. And one of them is odd. Those are two different cases, okay? So if n and m are both even, then we have to use sine squared of x is 1 minus cosine 2x divided by 2. And cosine squared of x is 1 plus cosine 2x divided by 2. Okay? If one of them is odd, and actually both of them is odd will work as well, then we can pull off one of the odd ones and just integrate normally. Okay, so as an example, let's say we even have one like sine to the 7th of x, cosine to the 9th of x dx. Doesn't matter, we pull off whichever one we want. Let's pull off a cosine. I'm going to write this as 1 minus sine squared of x to the 4th cosine x dx. And then u is sine x, du is cosine x dx, and go forth and integrate. Okay. Let's move that over here. This was our previous examples. Okay. Now let's take a look at what happens with secant and tangent. Okay, and cosecant and cotangent are the same, they just have some negative signs. So what we're going to remember is that the derivative of tangent of x is secant squared of x, and the derivative of secant of x is secant of x tangent of x. Okay, so, well, integral of secant squared of x dx is then tangent of x plus c. Integral of secant x tan x dx is then secant of x plus c. Okay, so let's take a look at the integral. Let's put some limits on this one. 0 to pi over 4 secant to the 4th of theta tan to the 4th theta d theta. Okay, so what we can do here is, well, look at that. Secant squared is the derivative of tangent x, right? So let's pull something, let's write this as the integral 0 to pi over 4 secant squared theta tan to the 4th theta secant squared theta d theta. Well, we also need, we still have this secant squared. We have one of them but we do have some trigonometric identities, right? Sine squared theta plus cosine squared theta equals 1. If we divide that by sine squared of theta, we're going to get 1. Sorry, we divide it by cosine squared of theta. Tan squared theta plus 1 equals secant squared theta. Okay? So we get the integral from 0 to pi over 4 of tan squared theta plus 1 tan to the 4th theta secant squared theta d theta. If we let u be tan theta, okay, du is secant squared theta d theta. Okay, now let's go ahead and do the limits. We're not going to have to change this one back. So when theta is 0, tangent of 0 is 0. Tangent of pi over 4 is 1. Okay, so we're going to get u squared plus 1, u to the 4th, du. And that's a standard straightforward integral to do. Okay, I could probably even do that here. U to the 7th over 7 plus u to the 5 over 5 from 0 to 1. 1/7 plus 1/5. Okay. Oh, I guess you're going to make me do that. 12 over 35. Okay. All right. I'll see you all in the next video.